Hi everyone, today in Integrated Math 1, we're going to go over Chapter 7, Lesson 1. Here are the objectives. Make sure you write them down in your notes. Alright, so let's go over a couple things really quick. So when we're talking about exponents, we're talking about that little number here. And the base is going to be that bigger number. But what's important that we know is that the exponent number tells us how many times we're going to multiply the base number by. So this time, as you can see for this example, we have 3 to the power 4, which means we're going to have 4 3s. 3 times 3 times 3 times 3, which is also equal to 81. So the product of powers is saying to multiply two powers, you have to have the same base. And then we add their exponents. Notice in this example, we have b and b, which is why we can add our exponents together. 3 plus 5 is 8, so b to the 8th power. G and G. And then we know we can add them together. But it is very important that we have the same base. If not, we can't do this. Then we have the power of a power. To find the power of a power, multiply the exponents. So we have b to the 3rd power, this whole thing times 5. Well, think about this, like the parentheses always mean multiplication. So that's an easy way to remember it. 3 times 5 is the 15, so b to the 15th power. This case is nice because we don't have to worry about the same bases. We can just multiply straight up top right here, like in these two examples. To find the power of a product, we want to find the power of each factor and multiply. The way I remember this one, I think about it like the distributive property. Each item in here needs to be distributed with the exponent. So we have negative 2 to the 5th power, x to the 5th power, and y to the 15th power. And we simplify that, and we get negative 32 times x to the 5th and y to the 15th. Alright, so it's really important when we're dealing with exponents and these kind of equations that we actually simplify them. To simplify the monomial expression, we want to write the equivalent, which means the same, expression which each variable base appears exactly once. What I mean by that is I shouldn't have x and x in the same equation, x times x. It should be simplified as x squared, because that's the simplified version. There's no powers of powers, so no x squared. There's none of that. And the fractions must be in simplest form. So if you have 2/4, we need to reduce it to 1/2. That's a simplified form. So let's go over example 1. We want to simplify 5 times x squared times y cubed times 2 times x to the 4th times y. So when we're dealing with this one, let's just go ahead and combine like terms. So we have 5 times 2. We're going to combine those. Those are the same. Then we have x squared times x to the 4th, because those are the same. Notice how I'm combining them. Then I have y cubed times y, which is just to the 1st power, just in case you need to remember. And as you can see here, it's not in its simplest form. We have to finish this up. It's just ready to simplify. 5 times 2, that's 10. Then we have x squared times x to the 4th. Well, what we can do here, to be multiplied between here, we can do x squared plus 4. Notice they have the same base. So we can do that. Then with the y's, we can do the same thing because they are the same bases. So we have 10 times x to the 6th power and y to the 4th power. And there we go. It's simplified. Nothing else we can do to it. Now let's check out this next one. We want to simplify 3a squared times b to the fourth, all cubed. So 3a squared b to the fourth, and that's all going to be cubed. The thing about this, I get the distributive property needs to be distributed with each of the letters and numbers. So 3 cubed, a squared, cubed, b to the fourth, and that's also going to be cubed. So 3 cubed is 27. Then we have the power of powers here. So a, 2 times 3, and b, 4 times 3. So 27, a to the 6th, and b to the 12th. And there's nothing else we can do here, so we're done.